Hello Maths fans, welcome back, and this time we are looking at some more Maths Watch feedback and help on circle theorem proof, or proofs using circle theorems related to clip 184, but also part of a year 10 assignment, and this question was question 4 on that assignment. This looks intimidating, this question, lots of algebra, lots of words, but you should always be thinking words should make you happy because it's more information they're giving you to work things out. Okay, so read very carefully. Remember, you need to have your circle theorems to hand, or you should have learnt these by now, hopefully. Word for word is what you need to use if you're going to be using those. ADP and ABQ are tangents to the circle. Straight away, tangents, it comes up a lot, doesn't it? 3 theorems for tangents. Tangent, angle between a tangent and a radius is 90 degrees. Tangents from external point to a circle are equal in length, which we've actually got here. I'm going to write those on straight away. Look, that is going to be the same as that. So we'll put that on there. And the alternate segment theorem. Okay, now looking at this, I've got a chord here, but it doesn't look like alternate segment theorem is going to work here, because although I've got an angle coming from that chord, it doesn't reach the circumference. It's not on the circumference. Okay, and that's it. So just reading over here, it says, giving reasons for all the statements you make, work out angles DCO, CBO. Okay, all those angles. Let's take DCO first. Okay, DCO. Oh, by the way, something you should remember, you should have come across already, that isosceles triangles come up again and again in circle theorem questions. Because you've got a radius, a radius, a radius, any triangle in here is going to be isosceles. So for example, this is a radius, which is the same as that, which is the same as that side there. So OC and OD and OB are isosceles are all sides of isosceles triangles. Now, it doesn't mean these two isosceles triangles are the same, it just means that they are isosceles triangles. Okay, so I've got OCD is isosceles. Well, straight away then I know what OCD is, or DCO they've asked me for. Same thing, isn't it? DCO must be equal to X, if you look, because OCD is an isosceles triangle. Okay, now they may ask you, oh, why is that the case? Well, OC, I'll put in there because, did you know that this upside down triangle means because with dots? Okay, because OC is equal to OD, I'll put that in there as well. So nobody's going to complain that I haven't given enough detail. Okay, so I'm going to put that on my diagram. X, what have we got here? We have now got, we want to find CBO, this one here. Okay, well, we said that one already. Tangent and a radius is 90 degrees, isn't it? So all of that's 90 degrees, which means all of this is 90 degrees. So what must this angle in here be? Well, it's in terms of x. I can say that CBO must be equal to 90, the whole angle, subtract 2x or minus 2x. Angle between tangent and radius equals 90 degrees, right? And we don't skimp on these words, okay? You don't say, oh yeah, the angle between a radius to a circle is 90 degrees, or a tangent to a radius is 90 degrees. We want to say the angle between a tangent and radius is 90 degrees, equals 90 degrees. Word for word there. Don't be sloppy, please. So that's CBO done. OCB, so that's 90 minus 2x. Let me just write that in there. Remember what I said about writing onto your diagram so that you know it. Okay. CBO. OCB is this one here. Now, you can see there's another isosceles triangle here, so that must also be 90 subtract 2x. I'm going to write that in there. BCO, or they called it OCB. OCB is also 90 minus 2x, and you can say triangle OCB is isosceles. Isosceles triangle. Okay, again, we've got OC equals OB here because OC equals OB. Okay, right. Now, what else we need to know? BCD. BCD D. So BCD must be the whole of this angle here then. So BCD is just those two added together. So BCD is equal to 90 minus 2x plus x. That's just a bit of algebra, isn't it? 90, negative 2x plus x is minus x. Okay, so we've got BCD. God, it's a long question, this one, isn't it? Okay, so what have we got now then? Hence, work out obtuse angle DOB, this one here. And hopefully you've noticed that's an angle at the centre. So I'm going to write that here. Okay, so DOB, and that must be twice the angle at the circumference. Well, there's the arms of that angle at the centre, O to B and O to D, O to B and O to D, so the wrong way around. If I bounce an angle off the circumference from D and gets back to B, this angle here, if I double that, I'll get this angle here. So we can say that DOB is equal to 2 lots of BCD, which equals 2 lots of 90 minus x, which is 180 minus 2x. Excellent. Right. So again, go into my diagram. Okay, now, what are we after? We're after y, aren't we? Now, to find y, lots of different ways to go about this. Okay, I'm going to go this sort of, maybe not the quickest way, because there are other proofs you could bring into this, but I'm just going to go through probably the most logical way if this is the first time you've seen a proof like this. You've got a quadrilateral here. You've got OD, A and B is quadrilateral. We know that's 90 degrees, and we know that's 90 degrees because they're angle between a tangent and a radius. So let's write that in there then. ODB equals OBA. ODA, sorry. Is that right? ODA equals OBA, which equals 90 degrees. Angle between tangent and radius. Okay, so, and we've got that angle there, so this is quadrilateral. Therefore, what can we say? Y must be equal to, all the angles got up to 360, haven't they? So it's 360 minus 90 minus another 90 over here, and subtract also 180 minus 2x. Now watch, those people who do not like losing brackets, this is where you will have problems. I've subtracted the whole of that angle. That negative, remember it's like a little negative 1 outside that bracket. It's going to affect everything inside there. So watch what happens here. 360 take away 90 is 180. And negative 1 times 180 is negative 180. And negative 1 times negative 2x is positive 2x. Okay, so what have we got? I've just worked that bit out there. That gives me that 180. And I've multiplied out that bracket. 180 minus 180 is 0, so y is equal to 2x as required. Ta-da! Okay, so hopefully that's, see that slipped off there. Just have to look at that again. Okay, 360 minus 90 is 180. Multiply out the bracket. 180 minus 180 is 0, plus 2x gives us 2x as required. Quite a tricky one, that. So good luck. Hopefully you understand that. Any questions, please message me, and I'll see you next time.